Question 1. How should I properly care for and handle my microphones? Answer. Caution should be taken when handling these sensitive instruments. Question 2. When should a surface microphone be used? Answer. Surface microphones are used to measure true surface pressure and noise. They are optimized for measurements in confined spaces and to reduce wind-induced noise during testing. Question 3. I need to take sound pressure measurements in a confined area or a high-temperature environment. Which microphone should I use? Answer. Probe microphones are recommended for small, hard-to-reach and high-temperature up to 800 degrees Celsius areas. Question 4. In my application, I need a cost-effective way to perform sound pressure mapping, beamforming, holography or noise source location with multiple microphones. How do I do this? Answer. Array microphones offer a lower-cost solution. Question 5. Can noise floor calculations be used to discover sources of unwanted noise? Answer. Yes. During product testing, noise floor calculations can be used as part of the product design process. Question 6. What is the noise floor of a microphone? Answer. The noise floor of microphone is defined by the cartridge thermal noise specification. It is important to note that the electrical noise of the preamplifier will impact the noise floor of the microphone and preamplifier combination. Other components in the measurement chain, for example power supplies and data acquisition systems, can also be limiting factors and increase the minimal sound pressure that you can measure. Question 7. Which microphone is recommended for low-frequency measurements? Answer. Low frequency is a relative term. Standard half-an-inch condenser test and measurement grade microphones have a -3 dB point of 1 Hz to 3 Hz, which is sufficient for most applications. Specialty microphones have been developed to exceed that and measure as low as 0.1 Hz. Question 8. What microphone is recommended for determining the direction or noise source location of sound? Answer. Multiple free-field microphones spaced in a predetermined pattern and combined with the appropriate software allow spatial transformation of a complex sound pressure field to be projected to effectively map the acoustic energy flow. Array microphones are an excellent choice for large channel count acoustic testing due to their overall value and phase matching specifications. Transducer electronic datasheet (TDS) are recommended since they enable the user to quickly and easily identify a particular microphone. Question 9. What is a polar plot and how is it used? Answer. Polar plots, also referred to as beam patterns, show a radially symmetric view of the angular dependence of the sound pressure detected by the microphone. The data provided in a polar plot will show how the sound pressure level detected by the microphone changes at various angles of incidence. The angle of incidence used is typically a 180 or 360 degree arc with the microphone at the center. The pressure amplitude decreases as you move from the center. Polar plots do not show the frequency dependence of the measured sound pressure and are always acquired at a specific frequency. The measurement frequency should always be specified with polar data because the shape of the beam pattern will change at different frequencies. Question 10. Does the size of a microphone impact its frequency and dynamic range? Answer. The size of microphone and its sensitivity does influence its capability. Typically, microphones with the smaller diameter and lower sensitivity allow higher amplitudes and frequencies to be measured. Conversely, larger diameter and or more sensitive microphones provide lower noise floor and lower frequency capability. Question 11. When measuring sound with test and measurement microphones, do I need to be in an anechoic chamber? Answer. Anechoic chambers allow measurement of low noise levels without reflections. Whether an anechoic chamber is needed depends on the application, what is being measured, and the environment. Anechoic chambers are generally required when you need to make free-field measurements in a location free of objects that could reflect sound. This is particularly true at lower frequencies where a large amount of space is required to obtain a free field. Anechoic chambers will be limited by the amount of absorption they provide. Typically, at frequencies below 1 kHz, most anechoic chambers provide very little absorption. In most cases where the signal-to-noise ratio is sufficiently high, an anechoic chamber is not necessary. Question 12. Can a 1/4 inch microphone be used with the high-temperature PCB model half HT426E01 or other vendors' half high-temperature preamplifier? Answer. Yes, a 1/4 inch microphone can be used with the PCB or other half-an-inch high-temperature preamplifiers, but a 079A02 adapter to connect the 1/4 inch microphone to the half-an-inch diameter preamplifier is needed. Question 13. What is the difference between PCB model 130E22 and model 130A23? Answer. Both are free-field array microphones with an SMB connector. The 130A23 uses a different design to allow for less variability in frequency response up to 20 kHz and increased dynamic range. The 130E22 allows more variability at high frequencies and is priced more cost-effectively. Question 14. What is the difference between absolute phase and relative phase for condenser microphones? Answer. Phase represents the delay between an applied force, electrical or mechanical, and the response to the applied force, electrical or mechanical. This is characterized as absolute phase or relative phase. Absolute phase is the intrinsic phase delay of the microphone and is independent of any external references. It represents the delay between the incident pressure and the output electrical response. Relative phase is the delay between the output electrical response and the response of another microphone. Any relative phase measurement must be established against a standard. Question 15. Is it safe to use a microphone at its maximum rated temperature? Answer. Yes, you can measure to the maximum temperature rating of the PCB microphone as long as the mated preamplifier is rated to at least that temperature. PCB microphones are tested to beyond their maximum temperature. It is important to note that every microphone requires a preamplifier, and in many cases the preamplifier can limit the microphone and preamplifier mated system temperature specifications.